Hi everyone, in this next video we're going to discuss the second method of separation technique. We call this method filtration. Actually, filtration is something you might have used yourself often without even knowing it. Let's say I have a tea bag. You want to make tea and you have a tea bag that you soak in water. In a sense, that's filtration. A lot of the tea that is inside the tea bag remains inside, and the smaller things are able to come out and seep into the water, making the tea its very nice bronze red color. But what's actually happening in filtration? And that's the topic for today. Okay, let's have a look at two of these beakers right here. I have two beakers. One beaker contains seawater, and the other beaker contains water and sand. Both of them are mixtures. I want to be able to separate the salt and the water. I want to separate the salt and the water. In this mixture, I want to separate the sand from the water. We're going to investigate what's the purpose of filtration by looking at these two mixtures. Let's look at the first mixture of seawater. Okay, you see this setup over here below. I'm going to tell you what each one is. This first thing over here, we call this a funnel or a filter funnel. If you look up here in the image, this is what the filter funnel looks like. Okay, this is what the filter funnel looks like. It is this is what it looks like in 3D. Over here I've drawn in 2D. Okay, next you also need a flask. This is what the flask looks like in 2D. This is what the flask will look like in 3D. Except I don't have a full image, but this is what the flask will look like in 3D. Next, you see this triangle thing I've drawn over here. It is the filter paper. The filter paper, you can see in this image over here, the filter paper. The filter paper is the special thing that allows me to do this process called filtration. Okay, so imagine I have a beaker of seawater. I want the salt. I want to take the salt out of the water. Okay, so this is what I'm going to do. I'm going to pour this salt water into this filtration setup. What you find is this. Yes, the seawater is going to collect here. Slowly, eventually, the seawater is going to pass through the filter paper and it's going to drip. It's going to drip and slowly fill up my flask. Let's zoom in to see what's exactly happening. If I were to zoom in to the filter paper, okay, this gray line over here is the filter paper. I have also drawn in some gaps. You can see these gaps over here. These gaps represent the holes, the microscopic holes that are present on the filter paper. Let's see what's happening when I put the salt water and against the filter paper. You see that in reality, both the salt molecules as well as the water molecules are able to pass through the whole gap present on the filter paper because both of them are microscopically small. Both the salt and the seawater, both the salt and the pure water, they're really small. Both of them will pass through the microscopic pores. Okay, I'm going to say, I said holes just now, but sometimes you can refer to these holes as pores. Both the salt and the dissolved salt and the water can pass through the microscopic pores because they are all really, really small. So we have a problem. Actually, this setup over here is not really good for filtering the salt out of the seawater. At the end of the day, this over here is still going to be seawater. It's not working. Let's look at this example instead. What about water and sand? If I were to pour the mixture of water and sand into the setup over here, Okay, let me choose another color. Okay, yeah, the sand is going to collect over here. Right, I'm going to pour the mixture of water and sand into the filter paper. Now let's zoom in to have a look. You find that you see the pores over here. You see the pores of the filter paper. You find that the water molecules are really small. They are able to pass through the pores of the filter paper. Right? They are able to pass through. However, let's look at the sand grains. You see the sand grains? Oops, where's that star? You see the sand grain over here? This sand grain cannot pass through the pores of the filter paper because it's too big. I mean, it's really small, but it's still too big compared to the microscopic pores. And so what you find at the end of the day is that one thing stays behind. The water molecules will drip into the flask, whereas the sand will remain behind at the filter paper. See the sand over here? It remains behind while the pure water goes through. I'm going to introduce some terms to you. We call the thing that stays behind at the filter paper, we call it residue. We call whatever that manages to go past through the filter paper, we call it the filtrate. Right? So in this case, sand is the residue, water is the filtrate. And if we compare these two setups, seawater, a mixture of seawater and a mixture of water and sand, the only reason why we can separate the sand from the water is because there is a size difference. There is a size difference between the two substances I want to separate. When I compare the dissolved salts and the water molecules, yes, there's a difference in size, but both of them are really microscopically small. If I compare the sand grain and the water molecules, you find that there is a large difference in size. Only because there's a large difference in size, therefore filtration works. So next time if you want to use filtration to separate anything, make sure that at the very least there's a difference in size between the substances you want to separate. That's why you can separate water and sand, but you can't separate the salt from the seawater. Okay, so that's all I have to share for this particular lesson on filtration. And I hope you can apply these knowledge and these ideas into other questions and puzzles. Thank you.